Hi, my name is Norberto and I am a software builder. That's what I do, and I have been doing that in different roles for almost 20 years. I am currently working as CTO for a startup fintech. I spend my free time with my wife and two little kids, and when I am not with them, I play guitar, piano, and other few things. I also like to work on domestic Internet of Things projects with an Arduino and a Raspberry Pi. I'm here today to tell you about Jukeberry, show a little recorded demo, and maybe do a live one with all of you at the end if everything goes well. So before moving forward, if you want to participate on that demo, please do. I want to encourage you to do that. And you have a node environment on your machine, please follow the instructions at the link at the bottom left to install the Jukeberry client on your computer. I really promise it won't delete your SDD. You can even check the code since everything is published on GitHub. Stay tuned to the comments on the YouTube channel for following up the demo at the end of the presentation. Jukeberry is a jukebox. You know, those machines that used to play music in bars around the decade of 50s and 60s. In this little remake, the way of choosing a song is by holding an RFID card near to an RFID reader. Each card has an associated song. For example, in this case, I have these ones, some Radiohead songs. That is a band that I love. So it's a nice gadget. It's relatively simple to develop. And if you are able to build some nice case, maybe one built in wood, it may look good in your living room during a social meeting. Of course, once COVID is over. Meanwhile, please stay at home. Well, what usually happens to me is that once one project is running, I start thinking of more features. Okay, and in this case, the features simply appear in my mind. I took a notebook and wrote this down, and later on, I pushed those to a GitHub repository so I don't forget it. You can check those draft ideas on the link at the bottom left of the slide. But anyway, I will tell you about some examples of those ideas. The basic one is playing songs, of course, but a more evolved one would be playing songs on multiple devices. Let's say you have a Chromecast, an Apple TV, a computer, a cell phone, whatever. For doing that, I need to build a network of connected devices that are invoked or notified when a user holds a card near the reader. Okay. Now, if I can have network of devices, that one needs to be differentiated from the network connected to a different Jukeberry, because of course I can build more than one Jukeberry. So I need a way to register Jukeberry or the network directly and the devices on each particular network. So suddenly I need some kind of device manager. I also need a way to manage songs. Let's say upload the song until it's integrated with Spotify. And I also want to have guests using their own cards or NFC compatible cell phones to play a song when they come home. So it seems like the manager should live on the cloud. But at the same time, I want the Jukeberry to be able to work even without an internet connection, at least for the most basic feature that would be just playing a song. As you can tell, the scenario became more complex and more fun. And now the project is heavily relying on using APIs to connect all these components. So what's about rest? Well, as I said, I live with two little kids. So getting rest is a bit difficult during the quarantine, believe me. But seriously speaking, what about going through REST APIs? Well, it actually could work. It is as simple as getting the Raspberry, calling an API on the device that will play the song. But what happens if I have several possible devices? Which one should I call? It seems like there should be some kind of logic at the Raspberry to route to the proper device, to the connected device. And if I want to do so, those devices should be registered within the Raspberry. What if the Raspberry is not available when one of those devices are going to register? If we think about it, we can solve that by deploying a separate component that manages that logic and routes the API to call to the corresponding device. The component must be developed, maintained, and more important, be available every time I want to play a song. Furthermore, we cannot expect the Raspberry or our Jukeberry to be a highly available component. I might have only one of those connected through my domestic ISP using a simple power supply. So registering a new device, managing songs, users, or any information that should be known by the Jukeberry are features that must be available regardless the Jukeberry. Lately, Jukeberry should be able to catch up when it comes available, asynchronously. It sounds like REST APIs are not suitable for doing that, or well, actually, it's not an issue with REST itself, but with the concept of building synchronous transactional services. You know, I call the API, I went until I get an answer, and either it's an okay or an error. If it's an error, I could retry until I succeed, and maybe that never happened. So it seems one of those situations where we could benefit from an event-driven architecture. Just in case it's the first talk you're listening today and you're not familiar with the concept, in an event-driven architecture, components are producing and or consuming events. These events inform something that happened instead of commanding something to happen, like a typical request. So a producer won't wait for any kind of response from any of the consumers. Furthermore, it may even not be a consumer for a particular event at a particular moment. Consumers observe events typically by subscribing to a channel and react upon this at their earliest convenience. Related to the jukebox, for instance, the Raspberry could produce an event describing that a card was read and publish it into a channel. That event might include information regarding the card, the Raspberry, the context, for example, at what time did the event happen. A set of devices might be subscribed to that channel and react to that event by, I don't know, in this case, playing a song associated to the card. If a particular device is not available at a specific time, it will simply miss that event. It makes no sense to start playing the missed songs when it becomes available. In that sense, it's a bit like the UDP protocol, in which if a datagram is lost or delayed, you're not going to wait for that since it won't make sense to use it when it reaches the destination. A different scenario is when a song is uploaded or registered. Since I want to manage that from different places and make it available for different users, I decided to place some service on the cloud. Every time a user registers a new song, the service produces and emits an event. The Raspberry subscribes to the corresponding channel to get a notification and store the song information internally, so it becomes available when the Jukeberry is offline. But the Raspberry may be offline when the song is registered. In that case, the event can be stored for different consumers to catch up later. And this concept is the cornerstone for another great idea, which is named event streaming. Event streaming states that you have a stream or flow of events that is capable of representing the state of a system at any time. You just need to read all the events until a particular time to replicate it. Tools such as Apache Kafka makes it possible to consume those events in an efficient way. And for sure, this scenario is more like TCP works. Packages can be delayed or arrive in a different order from the one that were generated, and the system must ensure this will reach the destination and that the message can be reassembled in the proper order. So going back to business, both scenarios are part of event-driven architectures and can benefit from asynchronous communication. And that's how this project meets the AsyncAPI initiative. So I started by writing a very simple AsyncAPI definition. First, I wrote the header, which includes some information about the project and the definition itself, such as the AsyncAPI version. I also specify the servers. This API is just for the media player part, which uses an MQTT broker. In this case, I am using an Eclipse Mosquito in the cloud, for which I want to thank to Solus that provided it. I also defined two channels. The first one is the corresponding to the event when a card is presented. The clients can expect a message to be published here when the user holds a card near to the reader. The message format is also defined on this section. The second channel is the stop push one. Clients can expect a message here when the user pushes the stop button. And there is a security scheme under the component sections. Components objects represent reusable objects, meaning that I can simply refer to this in other parts of the definition. Then I use an existing code generator for creating human readable documentation. I did it manually by running the command at the right button, but you can easily integrate that command to your continuous integration pipeline. So you have the documentation up to date with every API change. I used the same generator for creating the node client, which automatically solves the routing logic and leaves a clear handler where to implement the business logic. I had this client up and running in less than 10 minutes. Also, I was able to learn by reading the generated code. And yes, if you're about to cry, it's a proof of concept. It is okay to hard code some stuff when playing with technology, right? Finally, for the Raspberry code, I didn't use any generator. I think I will write the Python template for the code generator once I have some time. As you can see, the code for connecting and sending a message is pretty simple. And now it's time for the demo. I am going to record it right now and show it. And well, I don't know, let's play some music. So for the demo, I have a different setup here on my desk. The reason is that I need to record different components. I have this support for the camera. It's really domestic. First of all, I am going to present the 3 cards that I have prepared with different songs, all from Radiohead, which is the band that I love. Okay, what I'm going to do is to move this close to the reader and start playing. For that, I am also going to switch to a different camera. Well, we are also using a different microphone so you can catch the noise from the environment, which is the one that is more proper to listen to the sounds. The reason why I have a camera pointing to the screen instead of doing a screen share is that I want to simply start the node player, but after that I want to be able to show the device. Yes, this is the Jukeberry up and running. It's a Raspberry Pi 3 connected to well, different stuff. One of these is an RFID reader, as I said before. And what you have here is a button that I am going to push when I want to stop the music. So let's start by using one card, that is the clip card. Let's see what happens if I move it close to the reader. Okay, so enjoy the silence or the music. I am now going to try with a different card. Let's try to play high and dry. Okay, and let's move to the last card, it's for the snatcher, another thumb. Okay, so I think it's enough demo for now. I'm going to push the stop button right now, and it's going to stop music. Yes. Okay, that's all for the demo. Maybe we can try right now to do some online one if you have already installed the client.
Okay, folks. So great presentation, Norberto. I think you want to do a live demo, right? Right now.
If it's possible, it's an experiment.
So let's do some quick things here. I think you all are seeing my terminal, right? I'm gonna run. I was already running previously the code that we shared on the YouTube chat to configure Norberto's Jukeberry client, and so I'm gonna just run npm start to run it. Okay, so Yes, you all can see it. Perfect. So this is the MQTT client listening. You can probably already use it or do the demo, Norberto, or explain what's happening here. But let me just do something. Since I'm using my earphones, you will not you will not listen the music, right? So I'm gonna
Okay,
disconnect this.
that's clever,
Okay.
and I am going to do some signs with my hands so you can understand what I am speaking right now.
No, I
So
hear you.
we
I
now,
hear
oh, okay, just okay. So we have 16 connections. It means that 16 people should be able to listen to the music once we start playing with this. So once again, I have the cards here. It's really homemade, so nothing very fancy. What I'm going to do now is to switch the camera so you see the Raspberry. This is it, okay, in the flesh. And I'm going to start the program here on the Raspberry Pi right now. So everything should be working. And I'm going to start with this random card, and you will let me know if it's working. Okay. Also with the comments in the YouTube channels. I hope it does. It's an experiment once again.
Nice.
Yeah, I hear it from here. Yeah, people on people are hearing as well. So let me switch to another song just very quickly. As you can see, I really love Radiohead. So I'm going to do all the demo with this. And I am going to end with this one. So turn the volume up as much as possible at home. So I will set some endorphins on your torrent, okay? I hope I hope everyone are dancing there at home, okay? So the last thing that I have is here. Um, my stop button that I push so you can hear me again. Um, yes, okay, so it seems it's working. I'm really happy of having that working. I'm going to switch the camera again, but I think this is it. What do you think?
That's really amazing. Man, I loved it. I really wanted to share this with the people. Like we I was telling Norberto the other day, like we have to do this live. We can pre-record a demo, that's fine, but it will be cool for people to see it live, so we can share the code and they can experience themselves on their machines, right? So this is amazing, man. I mean, congrats for doing this, and I'm so happy that you did it with the async API generator. I mean, it's like
Yeah, and then and I will contribute to the Python as well.
oh,
When I started with this project, I didn't write Python code at all, and now I can contribute to the generator as well. I think
awesome.
it's a great initiative, and I love being involved somehow with some open source projects, something that I really missed.
Yeah, no, that's for sure. In that sense, I need to. I think I need to mention the great work the Solaz folks are doing on the code generators on Java and the Python now. So so Michael, not Mike. So Michael is working on the Python generator, and I think you should probably coordinate there. Even not just you, but not just you, but the whole community. If you're interested in a Python generator, I strongly suggest that you all coordinate the efforts there because it will be really cool. By the way, I mean Michael Davis. Okay, so I said Michael, but I didn't say who, which Michael, right? I was meaning. So yeah, he's doing a great job, and yeah, so my round of applause for the Solax folks here, doing a lot of great contributions. Um, Let me just check the chat because we have time. We have a lot of time for questions. So so yeah, and is there anything that you want to ask? We have lots of time for questions in this talk, so feel free to jump in and chat, and I'll 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 be happy to read your questions aloud here on the live stream. Um, Yeah. So, well, I think yeah, that's a good question. So someone's so Mobile Jones is asking where to find the Python generator. It's not yet done. It's actually something that we're now starting to work on. Let me just share this with you folks because I think I already created a repo for Michael Davis some time ago, and maybe we can share that. And let me find it. So this is, if I'm not mistaken, this is Bajo something. Maybe, yeah, Python Bajo. So we're gonna be creating an AsyncAPI code generator for Python using the Bajo the Bajo framework. Oh, look, so so Lucas has been faster than I. Perfect. So yeah, and if you have look, so Tamimi has a question for you. So curious to know, have you considered using other messaging protocols apart from MQTT?
Well, actually, yes and no, because for this I wanted to go with MQTT since it's very prepared for Internet of Things projects. So it was kind of the obvious decision to make. For sure, before that, I was considering doing all this stuff by using RESTful APIs, so just HTTP, but it didn't seem proper because of the reasons that I mentioned during the presentation, the synchronous and transactional part that I didn't want to. But the funny thing is that for being able to sync, as I said, all those other services that should be available on the cloud while the Raspberry could and probably will be offline, I will be using Apache Kafka connections so I can start doing event streaming. In part because it's useful, and in part because I want simply to play with the technology once again. So that would be the short answer.
Awesome, man. I think it's this experiment that you created reflects very well the usefulness of the MQTT protocol first, and it's very easy for people to understand that the value behind it, right? And that you don't have to jump into a big IoT project to see the value here. So that's
Exactly.
something really cool. And also,
yeah,
yeah, go on.
Maybe just a clarification. It's that I am using it for something that is really simple, and maybe I am going to generate a couple of events per minute. Okay, the MQTT protocol is thought, designed, and prepared for supporting millions and millions of transactions on short periods of times, because the magic with Internet of Things is that we are going to be putting sensors in all the world that are going to continuously be sensing information and sending it. So let's suppose that I want to change the volume of the songs on your computers by using a resistor here. I should be sending that in a continuous way, so it probably would be much more events per second. And even though that's going to be something very simple for MQTT, we are talking of servers that will be supporting high volumes of information that will be collected from devices, and after that processed by big data infrastructure and all the technology that will make possible big things to happen. Maybe it's super relevant for this context of the COVID-19. Where we could design some diagnosis mechanisms that actually triggers alarms or start measuring what's going on with population on different areas, so we can understand and follow the virus through different places. And I think that MQTT will be a main player for that.
That's so true, man. We have a curious thing happening on the chat, which I like it a lot. The things about being live, right? So David Viesak is asking us if you could play the music again. People will not hear it on my computer anymore, but he even suggests if you can be playing this during the whole conference from time to time.
I can do it. I think I am going to bother people, but it's always your choice to simply exit the client. Let me do it. I am going to do it. I am not going to switch the camera again. If you have 3 songs for choosing, if you want to leave a comment there and let me know which one you want to be hearing. So I am playing right now What is Natural.
Oh, that's I'm gonna turn off my client when this is killing my ears.
Oh, so it is on.
That's amazing. That's super cool. And also Michael Davis is asking like, how about we make a generator for MQTT on Arduino? I think that would be like super, you know.
Let me work on it in a couple of days. Well, let me a short anecdote here. Couple of days before the presentation, while I was working on it, my RFID reader just broke. I couldn't make it work anymore. And on the context of the COVID, it was very hard to find a new one until here the regulations start being more flexible. So I got a couple, one day before recording the presentation, I had to prepare it and make it work again. But in the middle, the solution was going to be to say, okay, let's see if it's working on the Arduino. So I will make the client to connect, actually the server to connect directly from the Arduino to the server, and the Jukeberry will work on that. And it won't be called Jukeberry anymore because it's Arduino. The thing is that I started with the Raspberry Pi because it already has Wi-Fi, and it already has a sound card. So before doing all that stuff with the MQTT, it was going to play locally, and that's the reason why I choose this.
Amazing. So thanks, Norberto, for joining us today. It's been I think it's been an amazing talk, man. It's again, thanks a lot. I really appreciate that you took also the risk, let's say, of joining live and doing this demo, this live demo. Thanks again. So
yeah, it was fun for me. Thank you.
Thank you.